Okay, so we've got our models loaded into Repetier Host, and Repetier Host is a free software that you will use for any 3D printer running a Repetier firmware. And we've already looked at how to load a model, right? So we've got our models here, and we've looked a little bit about selecting the model you're going to choose and then manipulating its scale, its position, which you can drag here or enter numbers manually, its rotation, and we can also scale just certain parts, so we can scale the X or the Y or the height. Okay, so let's just have one model here to work with. And before we can actually print this, I mean, you don't just click, run job. What we have to do is perform an operation called slicing. There's a number of programs that do this. So when you see this slice with slicer, Slic3r, that's a proprietary name. It's an external program. There's also Ski and Forge. Easy Slice is another program. If we were running Makerware, they've got their own proprietary slicing. What slicing does is it generates G-code. And G-code is the flavor of code to the XYZ, so it tells the printer where to move the nozzle head, and it also informs it at what temperature it should be running at and what speed it should be running at. So what you want to do is configure your slicer settings, or at least be comfortable with the slicer settings. This can resolve a lot of problems you'll have in the printing process. So we'll see a lot of things here, and I'm going to go over the generalities of most of them. Okay. So your layer height is your Z layer, and so if we print this cube right here, it's going to lay down. The first layer is going to be 0.2 millimeters. Then it's going to go 0.1, 0.1, 0.1, 0.1, 0.1, 0.1, all the way up to the top. Then you can adjust this up to, if you hover over anything, it tells you what the default value is. So everything you see now, I've adjusted it and manipulated it to whatever object that I'm printing. And I can tell you right now that most objects, to get a successful print, are going to have unique slicer settings. So if you hover over anything, you don't lose your track too much, because it tells you what the default value is, and that's a good baseline. These default values. So generally 0.1 is going to give you more overall detail than 0.4, right? And 0.2 more than 0.4 but less than 0.1. So we can think of that as a accuracy or a precision, a measure of precision. So this is what I would call a major variable. Okay. And you have your vertical shells, and these are the perimeters, the outside perimeters, and the base. So 3 of these are going to be what we'll call solid on the bottom, all the way around each side, and on the top, all solid. Here's some yes or no variables. Extra perimeters if needed. That's really specific to slicer. Avoid crossing perimeters. If this was checked, then the pathing would calculate for the nozzle never to cross an existing path on its own layer. So if we had a extruder that was leaky and or prone to oozing, then we wouldn't get this unnecessary buildup, or it wouldn't bump into um, material that has already been extruded. Start the perimeters at concave, non-overhang points, detect thin walls, and detect bridging perimeters. Again, these are some sort of variables that fit into the slicer setting specifically. Randomized starting points, so each layer should start at a random starting point so we don't get buildup, repeated buildup on one corner, and thus the corner that the layers are always starting at becomes higher than the rest of the areas. And then external perimeters first. By default, it's going to print the inside perimeter of the outside wall and then go around in a loop until the very last part is the outside perimeter. So, and so these are in the print settings. And we can go down to infill. Our density, a 1 density would be 100% infill. At what we have here is a concentric pattern. So all the infill goes around and around in loops. We can also have, standard I think is rectilinear. And you know, for example, we can have 0.5. So that means when it's doing its infill layers, and some of this will be easier to see if I actually, let's actually slice it. Ignore that. Okay. So here's all the code. Well, probably about 30,000 lines of code. And then here's the pathing. Okay. So the travel is in this light blue cyan, and then the actual filament or the extruded material is in this dark blue. Okay. So here's the perimeters that I was talking about. Here's the infill that I was talking about. So let's open back up the slicer settings. So this was a 0.5 infill, right? At a rectilinear 45-degree fill angle. Okay? So we can, anytime you make a change, you want to save it, and then, you know, you can just slice it again. And yeah, let's show you what you know, a concentric would look like. Save it. And there's the concentric. So you can see it goes around and around and around. And where it cannot do a concentric pattern, it looks like it's filling in with solid lines. There we go. Okay. So some other things here. We can force a solid infill every layer, but that's essentially the same thing as having a fill density of 1. We can adjust the fill angle. If we don't want a 45-degree angle, maybe we want perpendicular 90 degrees, we can do that. Yeah. So we go down to speed, and there's all sorts of default speeds, and some of these are adjusted. I personally don't like having the stepper motors speed up and slow down for different movements. So I like to keep a constant speed for travel and extrusion, but you know, this is there's a lot of room to play here, and this will affect the speed time and the quality of your print. Skirt and brim. Skirt is this these loops that we have around here. Basically, it's just a one-time thing. It primes the extruder. It makes sure you have good flow. And then there's the 3 loops for the skirt that we have denoted here. They're 10 millimeters away from the object. We only do it one layer. It's a one-time thing. We don't do it every single layer. Support material. So generate support material or a raft. If you had overhangs, so if this area came out at a 90 degree, we could generate support to build up so that we could have that overhang. That's advanced. It's advanced modeling, and it's risky. It doesn't always work. A raft layer can be a good idea, especially if if you have a large surface area on your object. You might want to put down a raft so that any warping will be limited to the raft and it won't affect your object. So we can put in a raft of 3 layers and then slice that, and we'll be able to see the raft here. Okay, so the raft did not show up. That's interesting. Raft. No, possibly because I don't have any interface layers. Let's give that a shot. I don't print with rafts, so I've got a good quality heated glass printing bed. I've never seen an advantage to a raft. Let's see if the model updates. And this doesn't want to generate a raft for this model, and you'll find that. You'll find that to be the case sometimes. So let's just take that off. Notes, any notes you want to be included with the generated code. Output options. Complete individual objects doesn't seem to work. So if I had 2 of these, it would print it would print one of them all the way and then come over and print the second one all the way. Whereas if I did not have this selected, if I had 2 of these models down, it would print one layer here, go over and print this layer, come over here, print the second layer, print the second layer, come over here, print the third layer. Again, that's something that doesn't always work either because it has safety limits, and it says, well, if I can't complete individual objects, I won't. And I've yet to see a case where it actually did complete the individual objects. Multiple extruders. If you can have multiple extruders so that you can have like multicolor printing. So for the first 10 layers it prints red, and for the second 10 layers it prints blue, and for the third 10 layers it prints red again. We only have one extruder. Under your advanced, the extrusion width, set it all 0 to be automatically calculated, and all these widths right here come into play right here. So perimeters extrusion width 0.4, infill extrusion width 1.28. And I've messed around with this because it makes sense just logically that all the extrusion widths would be the same. But I've seen errors both in the automatic generation of extrusion widths and or if I set them all to the same 0.68, for example. So that's something you can mess with. The filament settings, this is possibly the most important setting right here. Make sure you get the diameter of your filament correctly and take several measurements along the length of the filament that you're using. The extrusion multiplier is kind of a fudge factor. Essentially, I could set this lower and compensate by having an extrusion multiplier. That's essentially all that is. Then the temperatures. So the extruder temperature, this is what heats the element. So for the first layer, you may want to have something different than for every other layer. And then the printing bed, if you have a heated bed, which I do, you can set this. These degrees are in Celsius. Cooling, I just leave it as is. The fan's there. The fan keeps the extruder gear shaft cooled so that you don't get heat creep going up your filament and causing a jam. So, yeah. And then that takes us to printer settings. So you can customize this. Basically, when we see 190 by 190 by 95 by 95, that's this box that it makes. That's also your printer area. So this would be your bed size right here, and then the Z value would be the maximum height that your extruder can go up to. It's self-explanatory. Here's the G-code flavor that it talks about, and these are different firmwares right here that would be accepting of a certain type of G-code flavor that Repetier would put out. So it looks like we can actually put out a makerware G-code. That's interesting. What else we got here? Oh yeah, extrusion. This is another big one. So the retraction of the filament is actually when the stepper motor for the extruder for the filament itself actually retracts during movement, so to reduce oozing of filament. The default is 1. I've gone anywhere from 0 to retraction all the way up to 1 and everywhere in between. Again, it depends on the piece, and it depends on how often this extruder head needs to travel. And if you have 10 pieces of something, when it finishes a layer here and travels over here, if you've got 0 retraction set, then it'll leave a trail of extruded filament. So you'll get oozing and some, you have to rework the part after it's done printing, maybe sand down an edge or something like that. So here's the speed of the retraction, whether or not you want it to trigger. Actually, every time a retraction is triggered, you can have the entire extruder go up in the Z direction if you want to. Every time you change a layer, you can have a retraction triggered. And then the distance that triggers a retraction here, in this case it's 2 millimeters. So those are all the slicer settings. And again, I probably spent 30 hours, and those 30 hours are have a certain settings, and then print something, and then come back and change a setting, and print the same thing, and change the setting, and print the same thing, and change the setting, and print the same thing. I've done that over and over and over again. And right now, I can tell you the most important things are the temperature at which you melt or extrude your filament. That's the number one determinant of whether you're going to have a successful print or not, hands down. Also, accurate measurements of the diameter. And then everything else can really just simply affect how well the piece is printed. Unfortunately, I'd say right now, the state of tabletop 3D printing comes down to the willingness and the thoroughness of the operator finding a quote sweet spot. So for every piece you want to print, you're going to have to find a sweet spot amongst all these settings. And for every filament you use, you want to find a sweet spot for that filament. So when you find something that works, keep buying that particular filament, keep buying that particular brand. Always look for a filament that gives you a consistent diameter. So where if we're using 1.75 diameter, 1.75 millimeter diameter filament, we want it to be as close to 1.75 throughout the spool as possible. You can buy bad spools that in one area of the filament they're 1.65 millimeters, in another area they're 1.85, and it's terrible. It'll cause so much problems for your prints. So, okay, we think we have this at a point, and you notice we can slice this over and over and over again. It just generates the code, and we can save this code. If we want to, put it on an SD card and just run the SD card through the printer. Or what I have right now, I've got my computer hooked up to the printer, and that's what we'll do next. For the next video, we will actually print this object. We'll go through some of the firmware settings, and then we'll go some of the bed preparation, and we'll go from there. So that's on the next video, is actually printing the object, printing the object. And what I'm not going to show you in the next video. So right now, let's assume I have everything hooked up. I would simply hit run job, and it would start sending instruction to the printer to warm up the bed, to home the extruder position, and start heating the the extruder, and then it would start sending line by line, instructing the extruder where to move, and begin building this object. That's next video. Stand by.